things. We're the third largest auction house in the USA behind Christie's and Sotheby's. We auction everything from gold coins to mini subs to collectible memorabilia from famous movies like Rocky. We have auctioned things like the menu from the freighter that rescued everyone from the Titanic. All kinds of cool stuff like that. So we do all kinds of stuff. I specifically write mobile apps that help them basically ship out things that people win at auction. People think that auctions are very infrequent things, you know, they're kind of fancy and they're kind of big. Not really. There's a whole lot of, you know, sausage that gets sold and has to get picked, and has to get shipped, and things like coins and stuff. We have coins that look identical to the normal person. And the people that pick these things aren't numismatists. They're just regular people that have a job and stuff, and they have to pick the right coin, and they don't need to send out the $10,000 buffalo nickel. They send out the $5 buffalo nickel that the dealer bought. So kids will fill up their, you know, coin collections and stuff. So we have all kinds of problems and stuff there, and I write apps to help fix all that stuff internally. All right, so we're going to be talking about binding native iOS libraries. Everyone here knows what a library is in the C, C++, Objective-C sense. So it's not managed code, it's completely unmanaged code. It's usually a binary, it has a jump table at the beginning, and then pieces of code inside of it and stuff. All right, so what's native binding? How many people are familiar with Pinbook? Sadly, Pinbook. Okay, so those of you who don't know, this stuff is all like Pinbook. Just wanted to say that. We're going to talk about how to bind native libraries in iOS. There's a tool that will be shown how to use. I'll show you guys how to use. It does it called Objective Sharpie. We'll show how to use CocoaPods. You know what CocoaPods is? So CocoaPods is basically a package manager for iOS libraries. Yeah. And it's all based on GitHub, and it lets you basically go see some package out there, you grab it, Sharpie now understands it, and we'll set up all the binding for you automatically. We'll talk about some technical you may need to make. When Objective Sharpie picks the wrong thing, all y'all know C++ code can have all kinds of weird macros, pointers, virtual tables, all kinds of crazy things that we have done in the past, and all it was free game because you originally could write iOS programs in Objective-C, you could link in C and C++ libraries. Objective Sharpie has to understand all that if it's going to actually produce a binding that will work. And then we'll go a little bit in the depth about what Objective Sharpie is doing behind the scenes. So when you go see a problem, you might be able to fix it. It is complicated. This is not easy. So Objective Sharpie does a really good job of getting you about 90 to 90% the way there. But as you'll see here in a little bit, you do have to go clean things up, especially if you want the libraries to seem like a native C# library. So for those of you guys who have actually programmed in Xamarin, you'll notice a lot of interesting things like enumerators and stuff that are in the iOS Xamarin bindings that aren't there at all in the iOS bindings that people have to use on Apple and stuff, and using Xcode and Swift now. All right, library is any native iOS library written in Objective-C or C++. It can be a third-party dude on GitHub. It can be from Apple. It can be straight up .a file, which is a code archive for those of y'all who don't know. So it's basically it's all the code for the library. It hasn't been stripped. It hasn't really been processed at all or optimized at all. Or it can be framework files. For those of you familiar with iOS and the Mac, a framework file is basically a zipped version of .h files and .a files for various architectures and all kinds of other things that framework may need to have to deal with. Because you have different versions of iOS running on different bitness of processors, and you have all that for the Mac as well. Because there were 32-bit Macs out there. Now there's 64-bit Macs. It has to deal with all that bitness stuff. And people think that libraries have to be complicated. They can be a simple standalone methods, like say you have a okay, this is the downside of it. You can have a simple library that's a C or C++ library that does financial calculations. And you can go get that, compile it, consume it in C# like you did in all the other apps that you were using on mobile. It doesn't have to interact with iOS or have any iOS things to do with it all. Objective-Sharpie just basically looks at it. It's a .a file, has some header files, and it makes wrappers for it. So, already has the pinvote question. So this is exactly like pinvote. There were before the website came, I can't remember its name anymore, that had lots of Win32 pinvoke wrappers and stuff on it. There were various tools that people wrote to actually wrap it. This is a kind of a manual process, kind of a boring process, kind of a cut and paste process, because you're basically taking arguments, taking return values, you're mapping the return values from C and C++ to C# via whatever mechanism you have it. You could have macros that unpack bit fields. You could have weird void pointers that are getting unwrapped in a certain way. The tool may have an internal knowledge about how these very specific data structures look like, and it knows how to unpack all the pieces manually. It can have all kinds of things like that. So you're basically taking a set of wrappers, method calls, delegate protocols that are used in Objective-C, for example. And like I said, you can do this all by hand, or you can use Objective-Sharpie. So Objective-Sharpie, like I said, is a tool that looks at .h files and produces wrappers for them, command line based, and it's battle tested. So this is a tool. So all y'all familiar with Xamarin know they like to talk about how within 24 hours of OS release, they have API bindings, which is a very true statement. I think it might have slipped to 48 hours now for the latest one, but it's very soon after. So when a beta comes out, they have bindings for it. When the code actually drops, they have one really quick update of Xamarin that you can start using immediately, even if Xcode is changed. They deal with all that stuff. They've used internally for 3-ish years, 4-ish years. They released it, I guess, the beta version unsupported. So kind of on your own, I'll explain a story here in a little bit that will show how on our own we are. Another cool thing it does, I learned literally probably 2 weeks ago, it leverages CLang. So CLang is a C++ compiler that Xcode uses behind the scenes, open source C and C++ compiler, and it actually produces an AST like Roslyn does now for us in .NET, and Objective-Sharpie can use that AST, look at what it's done, and make decisions on how to wrap things based on that. So you see one of the command line, one of the ways you can use Objective-Sharpie is to actually take the Xcode proj that is in most things you get source for now. If you don't have source, you just use the .h files, and you create bindings for you, and you can make its best guess at it. But if you have actual whole project in GitHub, for example, that you can use, you can tell it to compile it, and Objective-Sharpie will look at the AST, and we'll try to make good decisions based on what it thinks the wrapping needs to look like. So workflow, so go find a library. It can be your personal library, it can be project on GitHub, you can have source code, not have source code. I'm going to show y'all this barcode scanner that I have. It's called the Linea Pro. It's the scanner they've used in the Apple Store since Apple Store's opened up. It's a really solid scanner, works really well with iOS. They don't produce source code for this. They usually get .a files and .h files for this, and some documentation. Run Objective-Sharpie against the library in various ways. Take the artifacts from the mapping. You'll get 2 CS files. Create a binding project in Xamarin or Visual Studio. Doesn't matter which side you go. We're going to be showing off Xamarin Studio, but it's kind of the same thing. You go to File, pick it, binding project, and then you add those files into it. You have the A file binding project, which you
Absolutely
absolutely have to have. So
.h
.a file, cross your fingers, compile, and then you can just simply add a reference to your iOS project from the add references, just like you would anything else. All right, like I said, you find your library from GitHub, from CocoaPods, or legacy code you might have. Like I said, it doesn't have to be iOS interacting code. It can just be a bunch of C and C++ methods you need to use. All right, so it's Object-Sharpie. This is URL. If you just Google it, it's a very unique name, so you'll be able to find the web page to get to it. Set up your library. Run Object-Sharpie on the folder where the library is at, and you get built-in effects. So I'm going to go show this off right now. All right, so can y'all see that command line pretty well? Yeah, make it bigger. Okay. I didn't do it. I didn't do it. You said about control? Come on, man. Come in.
It did something.
It did this. It scrolled. Which that's what I expected to do. I could just find bigger. Or maybe not, because it's hidden someplace probably. Where was this? Appearance. Be right here, wouldn't you? Keep text.
Change one.
Come on, let's change that sticker to. There we go. Much better. All right, so I haven't memorized these command line. So the thing I'm going to show off is the pop demo. Even more bigger? Okay. All right. Okay, that's just big. All right, so I'm going to show off the pop demo. So the pop is an animation library. It's the canonical Xamarin example that they give to show off. But as I'll tell you in a little bit, not all things are rosy in the land of Xamarin sometimes. All right, so maybe you can see that, maybe you can't. There we go. Get out. All right, so basically, what I did here was the classic. Let's see how far back in my command line I got to go. Nope. So I'm just going to grab this from. And I'm not on Windows. All right. So it's a component. So you can see basically there's a directory. You can see there's a directory in there basically. It's got the .h files in it. There's an Xcode project out here and stuff. So you can just open the sucker in Xcode and get it to compile. And so the first one I'll show you, basically this is a syntax. This is a real you get help out here. You can see how you do stuff. Stuff that basically gives you telemetry options. So if you want to keep your APIs secret for whatever reasons, you can tell it not to send telemetry back. If you tell it to, if you get bugs and errors and stuff, it actually will send them to back there. And actually, I've gotten responses from like, hey, we got this piece of telemetry from you. What were you trying to do? So they actually do kind of watch the telemetry and actually try to get back to people if you decide to provide your email address and stuff. You have things like this. Have Xcode. Okay, so you can see what kind of SDKs you actually have installed. You can install multiple SDKs, so if you use support back version, versions of iOS, you can, and stuff. I don't. We try to keep the latest and stuff at work. All right. So see how this goes. So what this is going to do is this is going to tell Objective-Sharpie to, hey, go compile the Xcode project. I want you to try to bind with the 9.2 SDK, and when you're done, give me a binding, please. Hey, cool, it failed. Oh. Change the directory. This is a pretty small project, so it compiles pretty fast. All right. So it's done. Let's go see what artifacts we got. Files. Oh. Okay, drop them out. Drop them out. Oh, this. Okay. There we go. If you don't give it a binding, it drops out there. All right. So we've created 2 CS files, API definitions, and structured emails. And we'll look at those in a second. So like I said, you'll get an API definition, which will contain the guts of most of the meat of what you need to do. Structured enums, it separates those out. You're also going to create an extras. Extras is where you can actually go make things look more like subscribers. You can add enumerators in there. You can change the names. You can change the order of arguments. You do all kinds of interesting stuff in there. All right. Let's go create a new project in Xamarin Fast. So I'm going to load something that I already had working. Not that one. You still get my desktop? Okay, cool. All right, so I already set this up, but I'll show you what you do. So you basically right-click on the solution, go to Add New Project, and you just go under iOS. You can't create cross-platform because this is iOS-only stuff, so create a binding library, and you'll get a skeleton. Let's call this food for now. So you get a thing called foo in here, and it'll create stubs for you. So you have a stub of an API definition. And it's kind of, this is kind of the documentation. There's not a lot of great documentation for it. There's there's really good web pages for it and stuff, but they're not really going to hold your hand and tell you, hey, we have an array of ints that are unsigned. You need to make sure that you do this in the binding. Now, having said that, it's well, why do they give us a stupid tool and stuff to do all this? They're not going to hold our hands. Well, having said that, if you go to GitHub and you search for Monotouch binding. So for those who don't know, Monotouch was the name of this Xamarin framework for writing iOS stuff back before Xamarin was an actual company. So they have a library here, and it's probably got close to 50 or 60. Some of them very non-trivial bindings. So if you have a question, you can go grab this GitHub, index it, and do searches on it. That's how I kind of learned how to fix things and the bindings for the other barcode reader that we were going to use when I had to actually bind them and write them myself. So I actually got, so this Linea one I'm using right now actually comes from in here, so you can go look at it if you want to. It's right here. It's called Linea Pro. And it was written a while back. It was written by a guy who's now at Xamarin too. So that's kind of cool. So anyway, it'll create namespace, name of your library in here, and some kind of simple instructions on how everything is supposed to work. Okay. All right, so the like I said, this is a list of all the instructions and stuff. So what you do is you'll come in here, you'll replace the stubs that it gives you with the stub with the actual artifacts that are in the binding directory here. And you'll also have to go find, so Xcode built an actual binary, which is in Sharpie build. That's not it. All right, trust me, there's an A file that gets produced in place. I found this a while back. Anyway, so what you do is you put it in here, you just literally say add files. I don't remember the last place was. Nope, it doesn't remember. Dang it. Anyway, so you go find the .a file, you add it in here, and something will happen. So, if you're doing XAML programming at all, so what it does is creates effectively a code behind file with it. These are the linker options that you have. We'll talk about this a little bit later because this is where some of the issues with what type of library it is, what architectures you're actually going to try to talk to, comes into play. All right. Well, no.
So Objective-Sharp is not on this. We do a lot of weird programming languages. So you can do all kinds of weird things in libraries, weird things in files. You have to kind of go manually check things. So what the API definition has in it are things called verifies. So they are regular attributes that Objective-Sharp drops in, trying to say, hey, you need to go look at this to see if what I intuited about this thing is right. So one of the most common things that happens in Objective-C library is Objective-C really doesn't have properties. But they have methods that return values. Simple values, not structs or anything like that. So what Objective-Sharp does, it takes a lot of these things. I can show you. There we go. So it does verify method or property in there. So it's getting to animation keys. So behind the scenes there's actually a method called animation or probably called get animation keys or something like that. And then it maps it to a property called pop animation keys, saying, hey, this is the right thing to do. Sometimes when it's a method, a simple method, you can't make it a property from Objective-C. Once again, for reasons. So if you get a really complicated native library you buy, you're going to have to learn a whole lot about the way things are bound, compiled, and linked to Objective-C, C++. You have to learn about the C-lang and executable chain. And it's not fun. I will tell you that right now. I had to do it for the other binding I had to do, which for reasons I will explain in a little bit. I'm not showing you. And it's a lot of, for those of you who've done C and C++ programming, it's like that. It's like counting bytes and arrays because they're packed in a certain way. It's unpacking the bit field. It's like, oh, this library, even though it says it's C++, it's got some C stuff in it too. And that, for those of y'all who know, there's C++, you can have obviously polymorphism in the way that behind the scenes it's managed, they do name mangling. So the class that it's in, the function, in the parameters, it writes this really weird thing behind the scenes that is unintelligible except for maybe the method name at the end. So it can disambiguate from all the different polymorphic methods that might be in that C++. And it's just all kinds of weird, crazy stuff like that. And it might not even be the writer's fault. Like the other barcode library I had, they got the module for the actual scanning part of this from a third party, and they didn't get source code. They just knew how to link it. So they inherited whatever weirdness was in that library as well. Their library was pretty nice and pretty easy to understand. That was what I actually had source code for. But then when it tried to talk to the actual barcode engine to set up crazy parameters like how strong is the laser, you want the laser on, and you want the 2D barcode imager on? Because most people think that barcode readers, for example, 2D barcodes are read by the laser too. No, it's not. There's actually a little CCD in there, takes a picture of it, and does image processing on it. Which comes from, guess what? Yet another party. So anyway, things can get really complicated. That's kind of the gist of this. So anyway, you have to go back, look at stuff. Verifies cause a compilation to fail because it's an attribute that isn't defined anywhere. And so that makes you go through and look at all of them. I would say, except for that one library, a couple of the other libraries, and we had a printing library that used Bluetooth printing. It came over, boom, 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 it just worked. So it depends.
did have builds for those.
Okay.
So in the
pop
pop example, I'll jump out here right fast. I'll show you guys. This doesn't actually compile anymore. So this is an example from the Xamarin website that I compiled and ran literally a year ago, probably this March, because I got a new job. That was my first gig, was to basically get all this native stuff working. And I compiled it, it worked, and for 11 months I thought, hey, this is going to work when I give my talk. I checked it out at the beginning of the week. Nope, it doesn't work. And it doesn't work for weird and strange reasons. So this is the error that you get. So this is an error. It's not a compilation error, technically. It's not like, hey, the syntax is wrong. This is telling you that, hey, I don't know how to make a trampoline. And a trampoline, in a quick explanation, is the way that it marshals parameters from Objective-C and C# back and forth. The thing that you don't ever see is the thing called the trampoline. And it just basically knows how to take an array of events, avoid pointers to pointers, whatever, and marshal them back and forth and stuff. In C# we traditionally call that marshal. And this broke because I found out this week that Objective-Sharpie doesn't support something cool and new that they introduced in iOS called native types. Native types, so iOS used to be 32-bit, it became 64-bit, and they had to deal with what we had to deal with in Windows a long time ago, running 32-bit code on 64-bit, or having pure 64-bit code. So all that mess happens. So ints are different, floats are different, everything else is different. So they have, like I said, they have a thing called native types. They have native floats, native ints, all kinds of other native things. And basically Objective-Sharpie now doesn't know how to convert those yet, because it's an unsupported tool. Yes, we would like to support native types eventually, but we'll get around to it. Sorry, go do these 20 things, here's some code to actually maybe get ints working. We're working on floats right now, and if you come with other bugs, just tell us. So that's kind of something that you need to know you're going to get into. Other thing we had, so at one time we had the scanner, which is the Linea scanner. We had the Grab a scanner. And for those of you who use Xamarin even infrequently know, they just upgraded Xamarin big time. They support Xcode 7.2 now, I think. They have a new build process. They support, like I said, all the changes in Xcode. And they literally broke our scanning support. So we could roll back to the Xamarin 2.0 or whatever it is, 4.0, whatever it was. Then we moved to the new version and it would break. We moved back. We sent a simple sample project and they were like, yep, it broke. But it's not our library. So, you go in there and you play with stuff. It wouldn't work at all. So basically we've been on the 8.1 version of our app, or iOS 8.1 version of our app for like 5 months. And then sometime in the past, probably 4 months, 3 months, one of the point releases fixed it. But it only fixed it for the Linea. The Grab is still broken, and we don't know why. So we had to basically say, okay, we're going to pick the Linea. We're going to pick them anyway. But the support kind of went away. And the Grab was kind of cool because the Grab had so one of the problems you have with hardware devices is, guess what? The hardware device has to be docked. And there's no pass-through debugging support for iOS external accessories. So if they want to put a lightning connector on, this is just a charging port. This does nothing else but charge. It doesn't do anything else. You can't pass debugging information through it. So the Grab had a really cool feature where you would run what's called the Grabber bridge on the device, and you could run the app and the emulator, and they connect to each other, and you can actually test scanning things. Because the other thing you learn when you do iOS programming is that the device is much different than the emulator. Not even the screen and resolutions and stuff, it's just the behavior. There's less memory on these devices than there is available to the emulator, even though the emulator is supposed to be an emulator. It's not a simulator like the Windows one is now,
It runs in Hyper-V and everything else and stuff. It's an emulator, so they get as close as they can to running, but they always tell you to run it on the device. So with this device, I always have to write code and debug on Xamarin Studio on iOS because it supports Wi-Fi debugging. So it was kind of a big pain point. Okay.
So I have this came at something similar. Like jQuery, they try this approach.
Mm-hmm.
The problem with those scanners is they have short range.
Mm-hmm.
Do you find like any scanners to know IS more like long range?
Like what is defined as long range?
Oh, like 4 to 8 feet, you know, like right now we have this AC 9000 from
Honeywell's?
yeah.
So Honeywell makes, I know they make a big, looks like a industrial size scanner. These are kind of made for retail and close-up work. Now, having said that, so literally I was doing a test. So we're having some performance problems on here. Only occur on the device, of course. So the scenario is when you're scanning stuff really quickly. So literally we have someone that has like a box of coins for a person. Let's say 700 coins. And the way they scan them, the way they process them is the box is big so they can tilt them back, and there's barcodes at the top, and they go beep, 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 beep. And eventually, when you get to a certain point, it starts slowing down. We have a list view, and something's happening in it. So as a test, what I did was I printed out all the barcodes and laid them on the ground. And I took the scanner, and I was standing up, so it was at least 4, maybe 6 feet. And I was able to scan with this laser. Now, having said that, the CCD, see, this is just that bar's in there. The scanner is laser only. The other scanner, the CCD scanner, will not do that at all. So that's one piece of criteria you need to think about if you're going to do long distance. You're going to have a powerful laser, which may or may not be allowed by law because it's a laser. A laser can point this at your face and it'll blind you.
Right now we scan from here to the door.
Yeah.
Because of the shelves in the warehouse.
Yeah, you want to do that. So you have to get a scanner that specifically does it. But I know, for example, someone has made a binding for the Honeywell scanners. You search on the Xamarin forums, there's a dude. Okay, not like the blonde one at all. There's one it's got. So they make there's another Honeywell one they make that's got a keypad on it and it's got like a grip on it. It's kind of bigger. That might be more powerful because you're limited by battery life. So lasers are going to need a lot of energy. Like one thing we were trying to do to help them out was you can set this barcode reader to actually stay on. The problem was it would die because they would use it literally for 4 hours. You know, they could use it for 8 hours a day. They could pick stuff that long that they're pickers. That's what they do. And if we left it on, it would last 4 hours. If we let them go beep, 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 like manually press it, enough cumulative time happened while they were scanning to give them another 4 hours worth of work. It was kind of interesting. It was kind of weird. All right. But that's the way the native bindings. Things can break. They can break very easily. They can, you know, these devices have firmware upgrades that we're not in control over sometimes. We've since remedied that, but they used to have an app used for calibration, and we didn't know that the app actually also downloads firmware when there's new firmware. Well, I mean, but you don't expect. The thing is, you would think they would do regression testing, but they don't. I was trying to think of a nice way to say it, but they don't sometimes. Sometimes they don't really care. They fix something, some huge bug or whatever, and they have regression testing, and the struct is off by 1 bit or a byte or something, and things just start breaking, and you don't know why. It's really frustrating.
I know we needed to do iOS application because Microsoft started providing Windows devices. You know, they just said, you know, maybe 3 years ago, hey, we have something, you know, it's coming. People didn't try to replace something. They replaced iOS to, you know, later.
Yeah, I know an RFID company here that I actually worked for when I was improving, and they were still using Windows Mobile 6.0.
Yeah, it's the thing we already know.
Yeah. And it works. I mean, it's, what is it, Visual Basic programming or whatever? To build screens and stuff? C-Sharp? Okay. All right. Not as bad. That's what I would think. Yeah. .NET Compact, yeah. Yeah, so. It's like I just do programming on iPad too, so. But I did the original, I programmed the original .NET Compact Kernel when y'all use like C and C++ programming on it.
It seems like a Windows 10, device, easy, but us Visual Studio guys, just easy to debug, so
Yeah. Yeah, people don't take it into consideration what the debug loop is like on these things. It's really, I really cried when we couldn't, they wouldn't let me keep the Grabba support in there. Because that was just easy debug. I could deploy it, I could run it, I could scan it. This is just, I'm back in C land where I'm, using console.writeline to debug everything. Best case, I can actually write stuff out to iOS log and then go to Xcode, look at the device and go, oh, okay, there's stuff in there. It's a little bit less latency and stuff than doing console.writelines and stuff, but it's not that much better. So be vigilant. Test. Don't ever think that because something was working or is working in the simulator, it's still going to work. All right, then we'll talk about things that do work. Linear Pro demo, yay! All right, so this is one of the libraries that I got from the GitHub repo that I showed you. And we did a little bit of tweaking on it because, again, a version of firmware came out and there actually was a feature we wanted to support. We wanted to use in it, where you could set with the scan heap volume and tones. With the linear, you actually can play sounds and stuff over it. You can give it an array of frequencies and durations, so you can play the music and stuff like that. We just wanted it so we could play different tones based on whether or not you scan something that was good or bad for some reason. Yeah. Yes, good scan, bad scan. Exactly. All right, so let's go with that. So, no, you do it through iOS. Yeah, this is just literally, so the reason this thing doesn't sound at all is because the Linear has a version of this that you can plug a headphone into. But it's not, it doesn't, so they have a passive the headphone jack on the bottom. So they have another one on the top, and they do VoIP. So you can use VoIP apps on here to actually talk to people securely or something. For some reason they have it. It might be a legacy from the Apple Store for all I know. But that's the only reason this thing can play sound at all, and it actually has any PCM control at all. All right. All right, so like I said, this is the Linear Pro. Created an SDK. We created a binding project for us. This one actually will work. And built Pig. Right, so same thing. This one has extras in it. So this shows you something to like, for example, scan view. So this basically does some stuff in here, and the reason we have to do this is because we have to marshal things as it pointers around and stuff for playing sound and setting the beat. There's some simple stuff down here to actually rewrite. Basically, you're rewriting some array of hints. This is memory location. And then telling it, hey, play this thing. It's a really weird and strange thing. They don't have something simple that would just marshal that for you automatically. But this is what we figured out. And this probably took me maybe a week to figure out. Maybe a little less. All right, so what cool stuff did I want to show you? All right, so one thing here. Let's see. There you go. So delegates in Objective-C are called protocols. And so this actually maps an internal delegate to a delegate that we can use in C#. So here's the definition. It's got a bunch of stuff in here. Like so, it's really connected to stuff. It's not the reason I'm looking for. Okay, we don't have it in there. All right, so that's what I want to show you. All right, so, all right, I was thinking something else was in the value file that's not. So you saw there was a Linea handler in there, and so that gets mapped to a dispatcher we actually can use. So in here, you have a mapping for event args, and these are mapped directly to the Linea stuff. So when you get a barcode get scanned, an event fires on the C# or a delegate fires, a delegate happens on the Objective-C side, it gets mapped to a event on here. The event args get marshaled. So it basically gives you things like what the barcode data was, which is the number, and what type of barcode. There's events that happen when you disconnect and connect the actual device, which I'll show you here in a second. It has event args for mag cards, but I don't have any mag cards. But we kind of added that because mag cards are also, we have a mag card we test with, but all the mag card stuff is also tied into RFID stuff, which we actually do want to use it for. When we go to like conventions and stuff and sell a bunch of things, we actually have people that are qualified buyers have little RFID cards we can beat and we can pay for them and stuff like that. And so, like I said, we have a simple dispatcher that we wrote here that handles all of the events that come in. Inside of the test screen, we have a simple configuration, so we get a handle to the device, and we just wire up events like we would in C#. So we get state change events, we get scanned events, and we get other events. Anything else interesting in here? And there's our wrapping for platelet sound. All right, so let's test something here. Let's see if this will work. So I'm going to disconnect this thing. Come on. All right, I can see Sean's machine. You can see my machine. Right. All right, Sean, you're messing me up. Let's see.
No, I did this
like literally right before the.
No,
I'm using
reflector.
Hmm.
Let me toggle
that right fast.
I thought
I would stay connected to it actually. No, it didn't work. Like I said, I did it a couple times in here. It's like, what's going on? Good old quit administrator. Yep. All right, let's flip this up. There we go. Here we go.
Okay.
On that screen.
On that screen. That's interesting.
That's like, yeah.
What's that?
Oh. It doesn't know how to show it. It's visible. All right. It says on the screen. What? Yeah, that's Firewatch. What does the buttons even mean? Let me toggle mirroring. Oh, there it was. Okay. There we go. Yay. Just have to toggle mirroring. Here we go. All right. So, event. Like I said, it's really hard to show you debugging on here, or I would set a breakpoint so you'd actually believe me. Anyway, get a barcode, what kind it is on here. You would think all the barcodes are the same, but they're not. That's a UPC barcode. One on the can is a 41 for some reason. Yeah. You can get that from the number of digits and alphanumeric, all kinds of other weird things. Some have checksums on them. All kinds of crazy stuff like that. I minimized everything. So we put in a, let's see. All right, more ways to make bindings. So you have hook pods. You can manually do it. You can pass in parameters, .h files, and run. In fact, for the Grabba bindings, the first thing I had to do was Objective-C would not handle the framework file at all. So the framework file is just a simple compressed thing. It's got a header directory in it for architectures that need to be supported, and .a for whatever architectures need to be supported. And there's like a module list of things. So you can have multiple .a files and some things. But it's what iOS uses when you consume things on iOS that are bundled up into frameworks and stuff. But anyway, Objective-C couldn't handle it, so I had to manually extract the header files out, put them in a directory, and put them to Sharpie at it, and let it loose on it. All right. So now we're going to go back and talk about link width. And maybe show you the syntax for CocoaPods right fast. Because it's all kind of, the command line stuff just kind of works all the time. Except when it doesn't. It is. I mean, it's like, you know, you could have, everything can be bound, you go through the verifies and stuff, and this works, and then this breaks. For some reason, you have to go speed and can't figure it out. So, let's see. So, like I said, when you drop a .a file in here, it creates a link width. This is a more complicated link width. So I'm going to show you that one. It doesn't have all this stuff in it. So all this is saying, hey, this is the .a file I need. Next parameters are all the different architectures that it can support. So we have ARMS v7, which is 32-bit. So for simulators, 64-bit simulators which you can run in. The framework is the frameworks are all of the iOS libraries
that the library are binding to will support. So this device has its own Bluetooth on it. It has, so they actually sell a larger version of this that's a point of presence purchase thing. It can have security stuff built in, and it manually shows something like SSL certs. Like this is verified by such and such, but it does it in a secure manner, and it talks to AV Foundation to actually show it on the device. So you can't be spoofed. There's weird things like that. And like I said, there's VoIP support in it, so it has a thing for media player right there. Now, your library doesn't have to do any of this, but this tells the linking module, hey, there may be symbols in external accessories, core Bluetooth, AV Foundation, or media player that you need for play, pause, all kinds of stuff like that. Let's see, other flags in here. Is this a C++ library? Yes or no? Or if you don't have it here, it assumes it's Objective-C library. So it assumes certain calling conventions and stuff. So it knows how to put the arguments on the stack and take them off. Smart Link and force load. So we're going back to the slides for this one, because this was kind of complicated. Then we've got CS. All right, so like I said, it's parameters particular for the particular library you're binding for. C++, what architectures, what frameworks. Okay, force load. So one of the things that iOS has had to do in the past is aggressively strip out code that's not being used. So if you don't call it, it does static analysis, or tries to do static analysis is probably the better word, and it strips that code out at the link phase. So a long time ago, Galaxy far, far away, iOS 3.0, these devices were very memory limited. They're really not anymore. They are in the sense they have probably a gig in memory, but they used to have 256 megs in them. So aggressive stripping by iOS was absolutely necessary to get things to actually work in it. So force load and Smart Link basically tell it to force all the symbols to link, like don't do anything. And Smart Link basically, that should say previous one. So Smart Link says, ignore what force load told you when you link it in iOS, but not when you link it for GCC. Now CLang on the back end. So behind the scenes, it's calling the regular linkers and stuff that are using the Xcode build chain. So in GCC land, and now CLang land, it needs symbols to be linked for various reasons. So it knows how to do certain things. But when it comes back over to the iOS side, Smart Link says, hey, ignore that thing I just told you and strip all the unused stuff out that we don't need. I guess it thinks it can do a better job than GCC/CLang did. And there's a bunch of other ones on there too I'm not going to go into that I hope you never have to deal with at all. Because that means you're really, really deep into C++ and CLang, and that's not a fun place to be. So let's try Cocoa Pods right fast. It's just going to be a I'm going to try this. Try it right before the meeting, just to make sure that it would work. Got that. There it is. All right. I should have this history by now. I didn't hear that. All right, I'm gonna do it. Let's just fix this. Is that syntax for delete? Or do I have to specifically say build? Yeah, I can't remember. I can't remember my Linux systems. All right. That's not the command I need. I need. Let's do this. I forgot it creates a Git repo in the directory that you're in. I don't know how to use CocoaPod. I really don't. I like typing in commands. All right, so this should be able to work. Just have a pause directory in there. So behind the scenes, this is just doing what the Xcode project build thing does. It just lets you work with this stuff. Just convenience remembers. And there's a way to set up CocoaPods where it's visible globally. So if you use a bunch of different projects for your iOS stuff, you can just do it from here. I guess like one cool thing I can show you too here that I forgot. So remember I said it wrote out various verifies and stuff in here? So if you actually pay attention to the output of Objective-Sharpie, it comes in here and it says, it tells you every single plate, it tells you how many instances of these various things you need to go look at. So it says 5 instances of method properties. So you go look at this, see if it's that. So the second one is, hey, we can't really determine if an extern is a constant or if it's something else. And then we have P invokes in here, which are basically the way that they will actually call method and stuff. You may have to go look at those as well. So anyway, this we actually teach you get a little bit of information out here. And so in the end, we'll look at it. Yeah, API definition and instruction notes out here, and it's ready to go. Build directory. Yeah. So you get the same stuff that you get out of doing Objective-Sharpie the other way too. Let's see. That is the end. I didn't realize it was that short. Any questions? Oh, so like CocoaPods. So CocoaPods is a really cool thing that the iOS people invented. So like I said, it's like, I think of it as like NPM. You mentioned another tool. It's more. What? Oh, Libya. Yeah, but so the problem with like CocoaPods, one of the problems with CocoaPods is that it uses a GitHub as a CDN, effectively. So there's no layer between CocoaPods and GitHub. And one of the problems is that so they're trying to be very nice. So whenever you use CocoaPods, it's doing a git fetch equals depth equals 1. So only gets the latest one. But the problem is that when you actually have to use it for other dependencies, you have to go back and get, because you don't know what version of blah this thing depends on. So if it happens to be back in the tree a little bit, it causes a lot of traffic. And if you use CocoaPods to do stuff, you might, in the middle of the day, you might notice it's very not responsive, or it'll just fail. Because GitHub is aggressively rate limiting them, basically. And they're like, well, we don't do any work to do a CDN. We don't give us any money to do a CDN. We really like CocoaPod. We really like using GitHub. And so GitHub said, well, we're going to rate limit you. 'Cause
Then I saw the other build machines. I mean, GitHub has a few hundred repo machines, and they got to serve everybody. So.
So there's CocoaPods,
It's an open source group. There are people that maintain a database of iOS libraries.
So they just basically go through.
So you work for CocoaPods development script,
I do not. CocoaPods does? I don't know anything about CocoaPods, so. Okay, I figured it's the iOS library. iOS library is an iOS library. I don't know what Swift outputs as far as archivable things, code-wise.
Because it's its own compiler. So I'm assuming it's creating object files someplace. So theoretically, at some point, you can call the object files and concatenate them together. That's just what a code archive is. It's literally a little header that says, I got these methods and stuff. I don't think you have parameter information. I think that's still on the object file. It's literally concatenation of everything, a little header up at the top that says, hey, I got 10 things inside me. They start here and end here. I don't think they're compressed. They might be. It's Unix, so they're probably archived. Literally, probably would archive. Oh yeah, yes, CocoaPods has got controls out the wazoo. Because everyone wants their own UI on iOS. Well, just we have the same problem. We're about to embark on our UI polish phase here in a little bit. And so maybe in 3 months I might be here giving a talk about the inspector. Because basically we're going to tweak the UI, and you know, if you Xamarin know, I mean, just building to a device takes about 3 minutes, regardless. And we don't have Blend, and we don't have anything else like that really for iOS. So the easiest way to do, I'm going to figure this out in the next 3 months, is can we use Inspector to tweak the UI enough where we sit down with our UX dude and go tweak, move stuff around, maybe write a little complicated code if I need to. And then see it instantly on the device. Yeah. Yeah. His stuff was more talking about an experimentary thing where you can make UI elements and just get some work. I actually want to be able to, because we have rich data and we don't have Blend and design time data and all that cool stuff that we've had. I mean, Blend has been something I've used in a lot of projects where I can sit down with the UX guy, even if it was the guy who actually built our UX in XAML, let's say, and just sit down with him and very quickly tweak things really quickly. Like move this over 4 pixels, move this down, and make this a different color of red. And with design time, they actually see everything too live. A lot of times when you don't have data, your form's just flat. There's obviously nothing in it. You can't see how the first and last thing work and how the state is going to look and complex interactions and everything else.
So what was the main feature?
Because we have C# chops. Because basically, this decision was made before I got there, but the explanation is that they were already a WPF app, so you have a companion app to this that lets us look at other stuff. This is literally for people that are running around and picking things and stuff. So they use MVM, they have, what's the good WPF chops, they have UX Designer there, did all the stuff. He's going to put polish on this app too, or he's going to show me the pictures, and I'm going to put the polish on the app probably. And like I said, that was the main thing.
Visual Studio, they're VS Shop already, so they're comfortable with all that entire understanding. Now, I said that Xamarin's presented challenges. Xamarin's been flaky in a lot of ways. We have to dev at my work on 2 machines. So I would much rather dev on a Mac with Parallels than to worry about network stuff. Like recently our builds were kind of flaky until they got the SSH build system in the new thing. No, we distribute. We have IPAs and we push it out via MOS. We have MOS 360 on all the devices, and we can push it out any app that we want to. So my MOS basically, when we decided to release, builds an IPA, sign it, and gives it to our distribution model. So I said we use MOS to push all. We don't go to each device and plug it in. Yeah, we don't really, the devices really don't belong, we don't let people bring their own device to work. So these are all iPods, because they have to be charged and stuff too, so. We don't know, I mean, they got